Hey guys, I'm going to go ahead and try to record this example. We didn't quite get to it yesterday, or today, however you want to say it. We didn't quite get to it, so I wanted to make sure that I show you how to use your calculator so you can evaluate some of these in your calculator correctly. So if you look at example number 3, it says find the area bounded by the graphs, and it gives you f of x being x to the fourth minus 4x squared, and g of x being x cubed minus 4x. Okay, and we're going to do this all in the calculator. So in your calculator, in your y1, enter your f of x. In your y2, enter your g of x. And I like to change that y2 so that it's a thicker line so I can tell the difference between my two graphs. Okay, so in my calculator, in my y equals, gotta go through and clear some of these out. So in my y1, I'm going to enter my x to the fourth minus 4x squared. In my y2, I'm going to enter my x cubed minus my 4x. I'm going to clear out everything else. And I'm going to push graph. Now, depending on what you had your window set at before, you might not be able to see your graph. You might want to change your window so that you can see your graph a little bit better. I'm going to go ahead and change my window so that it is on the x value. I don't know, let's do -5 to +5. And then on the y, let's maybe do -5 to +5. And let's see what that graph looks like. Kind of zooming in it a little bit just so I can see my intersections and the area in between those graphs. So on this graph, if you look really closely, aren't there 3 sections that have area in between the two functions, right? So it looks like from -2 to 0, from like a 0 to a -1, and from -1 to 2. Right? There's 3 different sections that I want to find the area in between. But I don't want to estimate. I don't want to think that it's -2 to 0 and it's really not. So let's go ahead and actually find those intersections. And I'm going to find those intersections by going to second calc. And I'm going to go down to number 5. And it's going to ask me for my first curve. So if I want to find the intersection that's over here to the very left, I'm going to go close to it and I'm going to push enter. It's going to say second curve, so it should pop up to your next function, and I'm going to push enter again. It's going to say guess. I'm going to push enter again, and it should give me that intersection point, which is at -2, which we thought it would be at. You're going to do that for every single one. They should cross at -2. They should cross at 0. They should cross at -1, and then last they should cross at 2. So you're going to have to do that for as many times that they cross. Okay, so now my next step is to set up the integral. Oh, look what I forgot to do. In my y equals, I forgot to change this y2 so that it's a thicker line. So I'm going to go ahead and do that. I'm going to scroll over to the left of that y2, and I'm going to push enter until it's a thick line. And let's go back and look at it. So that's my f of x, and then my thick line would then be my g of x. So this is going to help me figure out who's greater and how to set up my integral. So from -2 to 0, who's the greater function? Well, it looks like g of x, right? From 0 to -1, who's my greater function? Or 0 to +1, I mean. It looks like this time f is above, right? The thinner line, f, is above. And then from 1 to 2, it looks like g is back up on top. So if I go back and set up my intervals, what would my intervals look like? We have from -2 to 0, g of x was the greater one, right? My thicker line. Then we have from 0 to 1, and who was greater on that function, or that interval? My f function was? And then we have from 1 to 2, was it? And in that interval, g of x, oops, was greater than. So I'm going to set up my 3 different intervals. Okay? But in order to evaluate them in the calculator, you have to put in your g of x minus f of x. So that's when I'm going to go back into my calculator, into my y equals. I'm going to go turn off my y1 by going over the equal to sign and pushing enter. I'm going to go over my y2 and turn it off. And in my y3, I'm going to go to vars. I'm going to go to y vars. I'm going to go 1, and I'm going to select y1. Minus, I'm going to do the same thing and put a y2 in there. So vars, y vars, functions, y2. And so my y3 now says y1 minus y2, which is essentially f of x minus g of x. And so which one of the integrals is f of x, the bigger one? Which one do I want f of x minus g of x? The one from 0 to 1, right? This is the only one that's turned on. Okay, so I'm going to graph it. Now this graph is just the function of f of x minus g of x. And where do I want to evaluate, or integrate, I should say, f of x minus g of x? Well, I want to integrate it from 0 to 1, right? That was the interval that f was greater than g. So I'm going to go second, calc, and I'm going to go down to number 7. And I want to integrate it from 0 to 1. And I should get 0.617. I'm going to go ahead and round it to 3 decimal places here. Okay, that's my middle integral. Okay, I have 2 other ones though. So I'm going to go back into my y equals. I'm going to turn off my y3. I'm going to enter a y4 as y2 minus y1. So my vars, y vars, but this time I want y2 minus my y1. Okay, which essentially is g of x minus f of x. And on that, I want to integrate from -2 from -2 to 0. 8.267. Okay, let's do it again, because I also want to integrate g of x minus f of x from 1. Oops. I think I just messed that up. Hold on, let me do that again. 7. Upper limit, or lower limit, there we go. 1, 2, 2. So I've integrated it from -2 to 0 and from 1 to 2. I don't want to do the whole thing, because remember, in between 0 and 1, f of x is greater. So I get 0.883. So now let's go back to our integrals that we set up. And we said that the area from -2 to 0 was 8.267. The area from 0 to 1 was 0.617. And the area from 1 to 2 was 0.883. So if I want the total area, what would I do with all those numbers? Right, we would add them all together. I'm going to add them all together. It's not going to be exact because we're rounding all of these numbers, but if we all do it to 3 decimal places and we show all of our work, we should all get the same answer. 9.767 would be the total area in between those 2 functions. Okay, so that's what you would do on all the calculator things. Hope that helps. I'll go ahead and post this on my website along with the other 7.1b example.